everyone. Some numbers are square numbers. 1, 4, 9, 16, 25, and so on are the square numbers because you can rearrange that many pebbles into a square. 1, 3, 6, 10, 15, and so on are the triangular numbers because you can rearrange them into triangles. Are there more square numbers than triangle numbers, more triangle numbers than square numbers, or equally many of each? In some sense, this question is ridiculous. Infinitely square numbers, infinitely many triangle numbers, so there's equal amount of each. But on the other hand, the square numbers are sparse, go up by 1, 3, 5, 7, 9. The triangle numbers go up by 1, 2, 3, 4. They grow up less fast, so there should be more of them. How many more? Less than 10, there are 3 square numbers. Less than or equal to 10, there are 4 triangle numbers. If you calculate the number of square numbers, number of triangle numbers over number of square numbers, it seems to approach 1.41. That looks a lot like the square root of 2. The nth square number is n squared. The nth triangle number is the numbers 1 up to n. That's n times n plus 1 over 2. How many square numbers are less than or equal to n? We could have, we want sk less than or equal to the square root of n. So the largest that could be is the square root of n rounded down to the nearest integer. How many triangle numbers are less than n? Well, tk has to be less than or equal to n squared plus n over 2. Do some algebra, you get k is less than or equal to the square root of 2n plus a quarter minus a half, rounded down to the nearest integer. As n gets bigger, there's basically no difference between the square root of n and the square root of n rounded down to the nearest integer. In a similar way, when numbers get big, adding a quarter from the square root is not going to make a big deal. As subtracting a half is not going to make a big deal. So the ratio of the number of triangle numbers over number of square numbers is going to get closer to the square root of 2 as n gets bigger.